Alright friends, so today we are doing 2.5, the Fundamental Theorem of Algebra. We have some vocab here. So what is the Fundamental Theorem? If f of x is a polynomial function of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. Linear factorization, meaning I can write all of my factors as linear products. Complex zeros and conjugate pairs. Now this is something that's super important. All of our complex zeros are going to come in conjugate pairs. So if a plus bi is a 0, then we already know that a minus bi also has to be a 0. Factors of polynomials. Every polynomial of degree n greater than 0 with real coefficients can be written as a product of linear and quadratic factors with real coefficients, where the quadratic factors have no real zeros. So maybe those quadratics have imaginary zeros. So we're going to talk about some of this factorization vocabulary. Alright, so the definitions are going to correspond to the types of zeros in a polynomial function. So we have linear factorization, we have irreducible factorization over the reals, and we have irreducible factorization over rational numbers. So real numbers include things like your square roots. Rational numbers are everything like your whole numbers. And then a complete linear factorization, that's where you'll see your imaginary solutions and stuff like that. So we're going to do this example. We're going to start backwards. So here are the zeros to my polynomial. So I've got f of x equals x plus 2. I've got 0 happening twice, so x squared. If I have root 3 as a 0, that means that I've got negative root 3 and positive root 3. And then also, if I have 2 plus I as a 0, that means I also have 2 minus I as a 0. So writing those as factors, I've got 2 plus I and 2 minus I. So this would be a complete factorization. This is everything. You see your imaginaries, you see your square roots. Now, if I want to go to over the reals, that means I need to get rid of my imaginary numbers. So in order to do that, we're going to have to distribute this and multiply it out. I'm going to pause the video and I'm going to show the multiplication just so this video isn't long. Alright, so if I want to factor over the real numbers, that it can include my square roots, but we had to get rid of those imaginary numbers. So what I did is I multiplied these things together, and that got us with x squared minus 4x plus 5. So this is no longer our complete factorization. We're getting further and further. Now, if I want to factor over rational numbers, that means everything has to be a whole number. So we're going to have to go even further. And if I continue, this is fine, this is fine. I've got to get rid of those square roots. So I'm going to have to multiply those together. So I've got x squared times x plus 2 times x squared minus 3 times x squared minus 4x plus 5. So this would be a factorization over those rational numbers. Remember, complete factorization up top. Then we've got factorization over our reals. That can include your square roots because those are real numbers. And then getting rid of those for our rationals. All right, flip the page. So we're going to do that same thing here, irreducible over the rationals, the reals, and then completely. My suggestion would be to first start by just factoring this thing. So two numbers here that multiply to positive 13 and add to negative 12, I've got x squared minus 13 and x squared plus 1. So here, if I solve this, my solutions are plus or minus root 13. Those are irrational. Here I've got subtract the 1, so you get x equals plus or minus I. And those are your imaginary solutions. So irreducible over the rationals, that's exactly what that is. So I've got f of x equals x squared minus 13 times x squared plus 1. Now going a little further, that can include my square roots. So I can't have imaginary numbers because imaginary numbers are not real. So just factoring a little further, we've got x minus root 13 and x plus root 13. And if we're still in the reals, then we've got to keep it as x squared plus 1. And then our complete factorization is going to be all of those. So I've got f of x equals x minus root 13, x plus root 13, x minus I, and x plus I. So that would be our complete linear factorization, seeing all of those zeros solutions as linear factors. All right. Going down to the next one. So it says factor the polynomial in the below ways and then solve. So here my suggestion would be to take a look at your graph. So I would graph this x cubed plus 6x minus 7. I will give you a little hint. This thing crosses the x-axis at 1, so that gives me the fact that 1 is a 0. So if I want to write this as a factor over the rationals, again, I just looked at a graph. You could do the same. This is part of it. Now, I want to find what's left over, so I'm going to do some synthetic division with 1, and I've got 1, 0, 6, and negative 7. So 1, 1, 1, 1, 7, 7, and 0. So my other factorization is going to be x squared plus x plus 7. I can tell you right now, I can't think of two numbers that multiply to 7 and add to 1. So there's my factorization over my rationals. Over my reals, well, we need to figure out what type of solutions these are. So I'm going to do the quadratic formula. So I'm going to pause, you do the quadratic formula, I'll do the quadratic formula, and we'll come back. Doing the quadratic formula, I got negative 1 plus or minus 3 root 3i all over 2. So those are not real solutions. So factoring over the reals, I've got the same exact thing I had above because I can't include my imaginary numbers here. Now if I factor completely, that's where I can include those things. So we've got f of x equals x minus 1. Now we've got x minus the quantity of negative 1 plus 3 root 3i over 2. And same thing, x minus the quantity, I'll have to move this a little bit, of that same thing. So x minus negative 1 minus 3 root 3i all over 2. So here, this would be our complete factorization, and then we have those solutions. So x equals 1, and then we've got negative 1 plus or minus 3 root 3i all over 2. So there are my three solutions here. All right, I want you to try the next one. I'm just going to have the answers, so you try the next one, I'll talk about it, and then we'll move forward. All right, so we have our complete factorization here. I factored by grouping. I got x cubed plus 1 times x minus 3. Now x cubed, we factor here. If you need a refresher on that, I'm sure there's a million videos out there. And this doesn't factor, so I had to use the quadratic formula to find my two solutions. So over the rationals, I've got this. Over the reals, it's the same exact thing. And then completely, I can include those imaginary solutions. And then there are my zeros. Right, we have one problem left together, and we are going to do some sign analysis, everybody's favorite. So we are going to factor, and we are going to find where this function, where this polynomial is less than or equal to 0. So we are looking where this thing is below the x-axis. Now in order to do that, we need to factor over the real numbers. So I'm going to take this polynomial that they gave us, and I'm going to factor it. So I can take out an x squared. That is really ugly. I can take out an x squared, and I'm left with x squared plus 4x minus 5. Factoring more, we've got x squared. This factors nicely for us, so x plus 5 and x minus 1. So on my number line, that's why I have those numbers. And now it's time to do some sign analysis. So I always make it's like a t-chart. So I've got x squared, that's happening twice, so I have to remember to square that factor. I've got x plus 5, and I've got x minus 1. So what I'm doing here is, in these intervals, I'm picking numbers, and I'm testing them out to see whether I'm positive or negative on those intervals there. So, for example, I'm going to start with picking a number to the left here. So, negative 6, for example. And I'm looking for less than or equal to 0, so I'm looking for when my solution is negative in this interval. Negative 6 squared is positive, negative 6 plus 5 is negative, and negative 6 minus 1 is negative. So a positive times a negative, that makes this section over here positive. So that's not going to be part of my solution here. That is not going to be part of my solution here. Then I'm going to do the same thing between -5 and 0. So pick -3, whatever number you want, and do the same thing. Positive, positive, negative. So positive, positive times negative makes a negative over here. Keep going. I'm just going to fill out the chart. If you need to test it out, or negative, and then positive, positive. So I'm looking for when I'm less than or equal to 0. So I can be equal to 0. So I'm looking where my negatives are. If it was greater than or equal to 0, we would be looking at these positives. But I'm looking on this interval. And since I have that equal to sign, I can be equal to 0. So I'm going to include that within my interval. So my solution here, all of those negative things. So I'm at -5 with a bracket because I'm including to 1. Now, our solution would be different if we weren't allowed to be equal to 0, but in this case we are. Okay, so that's all I have for you. You have some practice problems here, if it lets me scroll up. Yes, so there's some practice problems here. Try those. I will post the answers on OneNote, and then there's also a worksheet attached. And that worksheet, you can find the answer key on OneNote as well. All right, well, I will see you on Monday, and enjoy your weekend.